Something that many students struggle with when they move from class 10th to 11th is how to interpret graphs. What are graphs? Okay. And you will be dealing with a lot of graphs. You would be required to plot some graphs. You would be required to identify some graphs. You would be given a formula, and then you would be asked how one quantity varies with the other quantity. How would the graph of that quantity look like? So this exercise is going to help you with that. Let's briefly look at the different types of graphs. So the first type of graph that we are going to look at is a constant function. Something like y equals 2. This f of x is same as y. Whatever I'm plotting on this vertical axis is represented by y. So y equals 2. If x is 0, y is 2. If x is 1, y is still 2. If x is 3, y is still 2, and so on. So if you plot y equal to 2, you're going to get this red line. Okay, that is the graph. That is a constant function. It does not change with the value of x. It does not change with independent variable. Okay. By the way, just to recall, this thing is independent variable. And whatever is plotted on the y-axis is your dependent variable. Let's look at the next graph, which is a linear graph. Now here, y equal to x. This graph is showing y equal to x. So if x is 0, y is also 0. If x is 5, y is also 5. Okay? What if I have to plot something like y equal to 3x? So if y is 0, or if x is 0, y would be 0. So 1 point will definitely be here, right? But if x is 1, y will be 3. If x is 1, y will be somewhere here, 3. Yeah? And so on. If you plot, you will again get a straight line, but its inclination will be different. So it's going to be a straight line with a steeper slope. This angle would be bigger. This angle, the tan of this angle, tan of theta, is called the slope. And this number represents the slope of that graph. Okay. If I have to plot something like y equal to 0.5x, now the slope is smaller than 1. Y equal to x, the slope was 1. Y equal to 0.5x, the slope is smaller than 1. So this will be represented like this. Okay, this would be your y equal to 0.5x, and so on. So if you change the slope, if you change this number, the slope is getting changed. Okay, m, this is the slope of this straight line. But the general equation of a straight line is given as y equals mx plus c. This is y equal to mx, okay? Y equal to mx, where m is 1 in this case. If I know this graph, how can I get from this to this? Some constant has to be added, which means what? You can shift this graph up by that constant. Okay, so this would be your mx plus c. So this would be y equal to mx plus c. Now this is something called transformation of graphs. Very, very important concept for you. You will be taught this in detail when you are just starting off with calculus. Okay. For now, let's just quickly get introduced to all the other kinds of graphs. Okay, this graph, it's not used in physics that much as it is used in mathematics. It's the graph of y equal to mod x or modulus of x. Okay, it looks like this. It is always positive. For any value of x, it just converts that value into positive. So modulus of -3 will be 3. Okay. So if x value is -3, the output will come out to be +3 only. So if x is -3, the output would be +3 only. Yeah. If x is 3, then also the output will be 3. So always it gives the positive value. Okay. So that is modulus of x. A quadratic function looks like this. This is a parabola. Y square equal to 4ax or x square is equal to 4ay. These are all different equations of a parabola. A cubic graph or a cubic variation, it's going to look like this. Okay. Something like this. This is a cubic graph. Now, this is also a cubic graph, by the way. So it has 3 roots, 1, 2, 3, because it's cutting the x-axis at 3 points. So cubic variations is shown like this. Similarly, you can just take a look at the others. Okay, root x goes like this. Similarly, you can take a look at the other graphs and just familiarize yourself with these. Some other important graphs is this. Very, very important actually. We should know how inversely proportional graph looks like. So if y is inversely proportional to x, this is how the variation would look like. You won't be considering, for most of the cases, you won't be concerned about the negative side of the graph. You'll just be focusing on the positive side. Okay. Similarly, 1 upon x square, this thing goes up, becomes like this, and this is what you get, and so on. Okay. We have familiarized ourselves with graphs and how to interpret graphs. Any equation, for example, s equals ut plus half at square. How is distance varying with time here? As you can see, distance is proportional to time square, right? Distance is proportional to time square. So which kind of graph will it be? It would be this graph. From Newton's second law, we know force is equal to mass into acceleration. If you have to plot the graph between force and acceleration, you consider this to be x, you consider this to be y. What you have is y equal to mx. So you know what kind of graph will this be? It will be a linear graph. The value of slope will depend on what number you have here.